Welcome back. We're back for more fun and games. Okay, so we installed GridWorld. We copied the folder. Well, I downloaded the zip file from apcentral.collegeboard.com. I unzipped it, and then we copied that folder to our Shush account. And you go, and we're doing code here in GridWorld code, in projects, in first project. So we're running bugrunner.java today. And we changed the header comments. Anyone who didn't get this, just type that up. Who didn't get this? Who needs this? Patrick, anybody else? I'll just print it out here. Okay, so file, printy print. I'll print a couple of these just for fun. Whoever needs it's on the printer. Okay, so this is what we're running. It creates a world which is basically a grid or like graph paper, right? And we add a bug, which is randomly located on the grid, and a rock, and then we run it, right? Okay, so how do you run it? Let's go to a shell. We have the shush in with the -y. Wake up, server. Wake up, server. Okay, thank you. All right. And remember, you can CD directly. Do I have a CD in here, like all the way in? There it goes. And what do I do? Oh, wait, I got to do this first. I always forget this. No. Okay, YouTube, hang on. All right, so I need to do this. There you go. So if you take a look at what's there, it's bug runner. We've already Java C'd it, but just for fun, the Java C line goes like that. Java C space dash class path space dot colon dot dot forward slash dot dot forward slash GridWorld dot jar space and the class that the tester runner class that you're running. And hopefully there's no errors there. And then we Java it this way. It's almost the same exact line, except we got rid of the C in Java C, and we got rid of the .java in the bug runner. And there it is. Okay, so you play with it. You can step it, see what the bug does. You can run it, so it steps for you. You can make it go fast. That's really, really fast. You go slow. That's really, really slow. And we answered a number of questions yesterday. Let's just catch up, everybody who missed that. I'm going to stop it. By the way, if you click on an existing object, the bug or the rock, you have methods that allow you to mutate the bug or access naughty bits from the bug, right? Likewise with the rock. There you go. If you click an empty space, it allows you to add a new bug or a new rock. And notice there's a flower in here because we were leaving flowers behind. All right. So if we go back to the reading, where is it? Did I open it? I didn't open it. All right, I got to go back here. All right, so if you go back into here, remember we're focusing just on this folder, this thing, which is your cheat booklet they give you during the AP exam, and the manual, the student manual. So let's go here. And this is where we left off last time. Okay, yeah, I think that's about it. Okay, so we're on page 6. Well, we actually did this yesterday, but I'm just catching everybody up. Alrighty, bring this down a little bit. So what's happening? The grid uses directions as on a map. North is up on the screen, east is to the right, south is down, west is to the left. The diagonal directions are northeast, southeast, southwest, and northwest. Okay. One attribute of the bug is its direction indicated by the antennae. Initially, the bug faces north when you construct a new bug. Make a bug, take several steps, and observe its behavior. Then add more rocks and bugs by clicking on empty cells and selecting the actors of your choice. Answer the following questions after you've done a run and a step. Okay.
Why does the rock show up in a random place every time?
Well, because that's what the bug class and the rock class always show up at a random location when you start. I think, yeah, you can actually. Look, if you click on the rock, there is a move to, right? So if you click move to,
oh, you have to do it by grid?
yeah, so all right, so right now it's at 8-0. That's a good question. Do you see the grid? Click on the rock and click on move to, right, Neil? Okay. In your simulation, click on the rock and then click on the move to mutator. This is a mutator that's going to change its position, right? Notice where it is. Mine is at 8-0, okay? So 8 is the row. 0, 1, 2, 3, 4, 5, 6, 7, 8. And 0 is the column. 0 column. Okay? What if I wanted it to go here? What place is this?
Apparently flowers came.
What if I wanted to move my rock, which is at 8, 0 to here? That's 7, 4? Okay, let's see. Row 7, 0. Is it 4? Are you sure? Let's see. I think it's 3, actually, because you start counting at 0. 0, 1, 2, 3. All right, so let's put in a 7. Or you can change it to whatever you want, but play around with this stuff. And we said 3, right? Okay, then click OK, and boom, it moved. Okay? So if you click on an existing object, you can modify it. If you click on an empty square, you can put stuff in there. Now remember, in our runner, we only imported the bug class and the rock class. Why is the flower class in here?
Automatic.
It's automatically there, generated because the bug leaves flowers behind. All right, so I could put another flower here. I could change its color or something, or get color. So can you change color? Let's see, set color. All right, what if I wanted to set color to this or to that? Okay, there it goes, see? Oh, it's phenomenal. What if I put another bug in here? What if I put another rock in here?
It's funny, it's like Tom and Jerry.
What if I put in a bug where I want to change the color? See, there's 2 rock constructors, 2 flower constructors, 2 bug constructors. Bug with a default color, bug with a color you want. Okay, let me use that one and change its color. Let's make it, green. Okay, there you go. And then if you step it, look what the bugs do. They move forward, but then look at the green guy. He's blocked, turns 45 degrees clockwise. Sorry, is that clockwise? Yeah. And then now the red one's going to turn too, and the green one's going to turn again. So the green one's turned to 90 degrees now, right? The green one can move, the red one can't. It's turning, and there you go, right? So that's the behavior of a bug. Look what the rock does, a hell of a lot of nothing. Okay, let's run it. Let's make it go fast. What happens to the flowers? They decay. All right, so let's go to the questions. Number 1, does the bug always move to a new direction? New location?
Yes.
No, because what if it's blocked? It's got to turn. It turns clockwise 45 degrees if it's blocked. And it keeps on turning until it can move. All right, in which direction does the bug move? Yeah. If it can move, which way does it go? No, whichever way. Once it's rotated and it can move, which way is it going? Wherever the antennas are pointing. That's where it's facing. Okay. What does the bug do if it does not move? We said turns clockwise 45 degrees. What does a bug leave behind? Flowers. What happens to the bug when it hits an edge of the grid? It has to turn, right? Depending on if it's a corner or an edge, it might have to turn once, twice, 3 times, whatever. What happens when a bug has a rock in the location immediately in front of it? The rock blows up, right? No. No, the bug turns. You know, we could rewrite the code and make it.
Yeah, rewrite the code.
We'll make.
Nukes.
Right, it'll nuke the bug. That'll be good. Yeah, we get the nuke bug. We have to make a mutator called nuke bug.
No, nuke rock.
Nuke rock, but that'll kill the bug.
Yeah.
Right, well, we'll have to define nuke rock to have a certain radius of destruction or something. And kill off everything that's there? No. All right, but we get ahead of ourselves. All right, does a flower move? What does a flower do? Decays. Ugh, disgusting. Does a rock move or have any other behaviors? What does it do? A rock? That's the behavior. Okay, fine. Can more than one actor, a bug, a flower, or a rock, be at the same location at the same time? Actually not. And we'll see that as we run this a little bit more. All right, so we're on page 7. Yay. Okay. Exploring actor state and behavior. When you click on a cell containing an actor, which may be a bug or flower or a rock, a drop-down menu displays the methods that you can invoke on that actor. Remember, a bug is an actor, is an object. A rock is an actor, is an object. A flower is an actor, is an object. Whenever you can say is a, you have a subclass. Rock is an actor, so rock is a subclass to actor. Actor is an object. This isn't English class, it's okay. Is an object. So an actor is a subclass of object, right? Remember, everything is a subclass of the supercosmic object class. All right.
Cool if you went and actually learned the object class. You just walk in to the page, you're just like, I know the entire object class.
Yeah, write everything in terms of objects. You're done. You could do that.
You know, every object that has and ever will be created in
Right.
the object class.
There you go. The methods that appear above the separator line are specified by the class that defines the actor. Those that appear below the line are methods inherited from the actor class. So these are specific to the bug. If you're clicking a bug, you'll see this. So these methods are specific to a bug. These methods are inherited from the actor class because every actor needs to do this. That's why a bug is also an actor. We're inheriting stuff. Okay. Experiment with the different methods to see how they work. Accessor methods will have their results displayed in a dialog window. Modifier or mutator methods will cause an appropriate change in the display of the actor in the grid. If parameters are needed for a method, you provide them in the dialog window thusly. Okay. Thusly, really. Okay, so let's go back to the simulator. There it is. And okay, I'm going to stop it. Okay, there you go. Now, what if I click on a rock? Notice a rock has one method only. It can act. Apparently, it doesn't do a lot in the act method, but that's all it does. But all this other stuff, get color, an accessor, get direction, an accessor, get grid, an accessor, get location, an accessor, these are all inherited from the actor class because all actors have this in common. Why rewrite all this code every time you make a subclass? Move to is a mutator. Put self in grid as a mutator. Remove self from grid as a mutator. Set color is a mutator. Set direction is a mutator. And toString is, well, remember toString, we inherited from the object class, and it's rewritten for your class to work. And did I miss your question? What?
What is remove from grid?
I guess like kill it off, basically. Yeah. All right, so we can play with this stuff. What if I wanted to get, all right, let me get out of here. Let me get one of the bugs, okay?
Set color is obnoxious.
Now look at the bug. This bug is facing south, right? Do you see it? Mine? You can click on yours, but mine is facing south. What if I click on it and get direction? Where is it? Get direction. Look what I get. I get 180. What the heck does that mean? My red bug is looking south. I clicked on its get direction accessor and I got 180. What does that mean?
It's 180 degrees.
It's 180 degrees from north. Right. Remember, it starts from north, and north is apparently 0. All right, look. What if I do the same? All right, this green bug, my green bug, if I do its get direction, what do you expect to see? Look at my green bug. Which way is it showing? Sorry, facing. Which way is my green bug facing, guys? Wake up. East. What do you think? How many degrees do you think that is? 90. Let's see. Click it. Get direction. Do you get 90? Yep. Play around with your bugs, but that's what my bug is doing. Which way is this guy facing? It would be northeast, which would be 45. Okay, let's see. Get direction on this guy. Is it 45? All right, so the assumption being that when you construct the bug, initially it points north, and we're going to call that 0 degrees. And then it measures angles clockwise, which is weird if you're in math class, right? We don't do that. All right, so north is 0 degrees, east is 90, south is 180, right? Okay. What else can we do? Let's see. What if I did remove self from grid? What do you think that's going to do? Bye. See ya. It's gone. Okay. What if I do set direction? Now it's facing 90. What if I wanted to go southwest? 210, really? What would be southwest? It's right now it's 90, which is east. And 180 is south. What would be southwest? 225, wouldn't it be? 45 more than 180? All right, let's see if that's right. Let's put in 225. Pick your own bug, put 225, see if it goes southwest. There it goes. Okay? What else can I do to this guy? Get color. Well, get color is 0, 255, 0. What? Why is it 0, 255, 0? I did get color on him. This is the RGB color scheme from Java. You can have up to 256 different shades of red in a palette, like an artist's, oil painting, right?
256, really?
Yes, 256, from 0 to 255.
I think 256 equals 100.
Okay, fine. So anyway, you have 256 shades of red to choose from, including 0, no red. 256 shades of green, that's the most green you can get, 255. And 256 shades of blue.
Hey, that's
So it's basically green, right?
That's 100 to the third is the number of combinations.
Yay.
Or 256 to the third.
All right, what else can we do? All right, what if I did can move? What do you think can move will give? On this green guy, on my green guy, can it move?
True.
So I should get true, right? Let's see, can move. And I get true. Okay? All right, so...
the wall, then you get no because it has to
Right,
turn.
exactly. All right, so on page 8, everyone with me? Guys, focus. I'm on page 8. Okay, if you select one of the methods in the menu, it will be invoked for this actor. As an example, click on the bug to see the menu of methods. Now observe what happens when you select set direction. We did that. The bug will change its direction to the angle you specified, or supplied, like I put in 225. Try selecting some of the other methods. What about the act method? If you invoked that method, the actor will behave as if it had been clicked with a step button. But no other actors will do anything. That's weird, isn't it? Let's see. If I just click on a bug and tell it to act, he acted, but nobody else did, because the step method makes everybody call act, but I didn't call everybody's act. Okay. Look what it's doing. It's telling me stuff about each grid location as I hover over it. Right? That's the 2 string, by the way. That's a 2 string right there. That's a 2 string, that's a 2 string, that's a 2 string, right? Okay. Where am I? No. Not there. Where's my, there it is. Bing. A bug will move forward or turn to the right. A flower's color will darken. The rock will do nothing. The step button simply causes act to occur once per object, every object in the grid. Exercises. All right. By clicking on a cell containing a bug, a flower, or a rock, do the following. Test the set direction method with the following inputs and complete the table. Well, don't we know what this is going to do? 0 degrees is? Well, let's do it. They gave it to you, but 0 degrees is? North. 45 degrees is? Northeast. 90 degrees is? I know, we're done. But 90 degrees is? Everyone, 90 degrees is? East. 135 degrees? Southeast. 180 degrees? South. 225 degrees? Southwest. 270 degrees would be west, right? Because you're starting with 0 straight up. 315? Northwest, and 360 would be north again because it's the same as 0. Okay. Move a bug to a different location with the move to method. In which directions can you move it? How far can you move it? What happens if you try to move outside the grid? All right, let's do that. Let's take a bug. Now, how far can you move this bug? Can you move it off the grid? By the way, where is this bug? Whoops. Where is it? My red bug. Where is it? 0, 0. What if I wanted it to go down here? Is that 9, 9? Yeah, the default window is 10 by 10, and it's numbered 0 through 9 columns and 0 through 9 rows, and it's row first. All right, so if I want to go to the 9th row.
That's a matrix.
Yeah, and the 9th column, I could do that. All right, click it. Go to move to. Where the heck did move to go? There it is. And if I put in 9, 9, and there it is. Now, what if I tell it to act? It's going to turn. What if I tell it to act? It's going to turn. What if I tell it to act? It's going to turn. What if I tell it to act? It's going to turn because it's blocked. What if I tell it to act? It's going to turn. But now if I tell it to act, look what happened. The flower that was there is gone. Remember, you can only have one object per location in the grid at a given time. So when I put that bug over here, it killed off that flower. Look, what if I move the rock there? Move the rock to 9, 9.
Kill the bug.
All right, let's kill the bug. Where's the bug?
9, 9.
No, I moved it.
Why did you put it again?
Where's the bug? I'm going to kill the bug with the rock. It's still row 9, but it's column 8. Okay, so row 9, column 8. And let's go. Now it's gone. But now if I move the rock again, you'll see that there's nothing there.
Oh, it's a magic trick.
It's amazing. So move to.
Magic trick, actually. You take the rock,
Right.
put it somewhere.
Exactly.
Back and the thing's gone.
I say I go to 5, 5, and somewhere in the middle of the grid.
Hey, Mr. Garcia, I don't suppose you could put money on the screen, and then
And it's gone.
the rock, and then it would disappear.
All right, so that confirms that one object per location at a time, right? So when I moved the rock onto the bug removed itself. Then when I move the rock again, there's nothing there, right? It's empty. All right, let's see. So we did all of that stuff. Okay, good. Can you go off the grid, by the way? What would be like out here? Say here.
Disappear.
What would it be? What coordinate would you use out here? 8, 10, or 12 or something, right? All right, let's see if I can take a rock and move it to 8, 12 or something. All right, so let's see. 8, 12. Go. See, look, huge error. Can't do it. 8, 12 is not valid, won't do it, forget it. Okay, won't do it. All right, so that's how far you can go. As long as you don't go off the grid, that's how far you can go. That's the answer, okay. Change the color of bug and a rock and a flower and a rock. What method did you use? We did this already. What method changes the color? You forgot? Oh, gee. Look. What if I want to change this rock to red? If I want to change this rock to a red color, what do I do? Where is it? Set color. And I could set it to, oh, I don't know, is red in here? Red, and there it goes. Okay, it's a red rock. Wow. All right. Move a rock on top of a bug and move it again. Oh, I did that. Remember what happened? It killed off the bug. The bug removed itself. We moved the rock again. There was nothing there. Okay, good. We did that. All righty. All right, so this is a summary of all the stuff we did. You can read that on your own. And we're in part 2. All right, so chapter 1 is done. That was tough. All right, so chapter 2. Here we go, part 2. Now, don't get all excited. Each part gets longer and longer. Part 1 was short. Part 2 is a little longer. Part 3 is long. Part 4 is long. All right, so here we go. Part 2 or chapter 2, bug variations. Okay, methods of the bug class. The bug class provides 3 methods that specify how bugs move and turn and stuff, right? Public Boolean can move is a predicate accessor. Public void move is a mutator. Public void turn is a mutator. Here's the act method, okay? Public void act. If can move, move else turn. Well, that's easy.
Oh wait, that makes sense.
Doesn't that make sense? It's almost like English.
Sub-method.
Yeah, exactly. It's almost like English. If can move, move else turn. Okay.
But that's so...
That's it. That's what the act method does. Now, in the AP exam, in the part 2 free response, there's usually one free response question where they're going to ask you to modify code. They could modify the act method. They could modify the move method. They can modify the turn method. They can modify the can move method, depending on what the bug is supposed to do.
So if you wanted to double the speed of it walking, you would do move.
You could do that. Yeah, sure. Right. So there's some very simple modifications you can make and some very complicated modifications you can make. And we're going to try to take a look at as much of this stuff as we can. All right, so public Boolean can move. Tests whether the bug can move forward into a location that's empty or contains a flower. Remember, this returns a true or a false. Public void move moves the bug forward, putting a flower into the location it previously occupied. Public void turn turns the bug 45 degrees to the right, or I would say clockwise, without changing its location. All right. The experiments in the previous section showed that the bug moves forward when it can. When the bug has a rock in front of it or is facing the edge of the grid, it can't move, so it will turn. However, it can step on a flower, which will remove the flower from the grid. Did you ever notice that? When, if the bug goes over a flower that it left behind or another bug left behind, it can do that. And it'll leave its own flower behind. It really killed off the other flower that was decaying. So when the bug moves, it leaves the flower in its previous location. This behavior is determined by the act method of the bug class. Okay. I'm sorry, the act method of any actor. But what it does when it moves, we can change. Extending the bug class. Okay. Why are you going so far? Stop. It doesn't want to go here. All right. There it is. Okay. A new type of bug, listen up. A new type of bug with different behavior can be created by extending the bug class. So we could have a new bug, I don't know, a Patrick bug.
No.
Okay, a Kyle bug.
No.
Kyle is a bug? Okay. No?
Make it some like silly name.
Okay, a Luke bug. Whatever. All right, you can make a loop bug, which is a bug, which is an actor, which is an object. So subclass of a subclass of a subclass, inheriting everything above. Okay, so right. Right. All right, so a new type of bug with different behavior can be created by extending the bug class and overriding the act method. Overriding the act method we're inheriting. Okay. No new methods need to be added. The act method uses the 3 auxiliary methods from the bug class that you already inherited. A box bug moves in a square pattern. In order to keep track of its movement, the box bug class has 2 instance fields, 2 naughty bits, 2 private variables, right? Side length and steps. Okay. Well, so look at this box bug. What's its side length, do you suppose?
The longer one?
Well, there's a yellow one and there's a red one. There's 2 bugs.
Yeah, the yellow one should be.
What's the side length of this bug? It looks to me like 7.
6, 7.
I don't know if it turns on 6 or turns on 7, whatever. And how big is this one?
4.
Well, 4, I'm thinking. All right, so what it does is it creates a square by leaving the flowers behind, right? It moves in a square pattern, leaving behind a square of flowers, okay? So this yellow bug had a side length of 7, I think, and the red one has a side length of 4. So this is a different kind of bug. This bug has another parameter, the side length. When it hits that length, if it's walked that far, then how does it turn? Is it turning 45 degrees? Look at it. When it runs through its old side length, it turned what? 90 degrees. So we're going to change how this one turns. It turns 90, not 45. You could like call turn. Do a turn. Right? Yeah, question?
What happens if the bug needs to turn at 90 angle, but there's already another bug there?
Well, then it'll probably keep on turning. Right? Remember, if it can't move, it'll turn again. But this one turns at 90-degree increments. Now, what if it's always blocked every time it does 90 degrees? Then it's just going to spin around forever. That happens too. All right. So here's a new bug, right? Box bug. All right. So the source code for the box bug class is in Appendix C. All right. Let's take a look at Appendix C. Now, what I want to do is go back to, whoops, not that. I want to go back to here and take a look at Appendix C. Remember, Appendix A is very nice. It's a summary of all the Java stuff you should know before you walk into the test. Everything you know about the supercosmic object class, the comparable interface we didn't talk about yet, the integer class, the double class, which we still have to talk some more about, the string class, the math class, which is a static class. You don't have to construct a math object, and the array list class, which we haven't talked about yet. But in Appendix B, they give you some information about all the classes. And notice, by the way, look at all these finals.
What are they?
North is 0, east is 90, south is 180, right? Public static final int north, public static final int east. Okay? So there's a whole bunch of finals we can use. And I'm going to skip Appendix B for a minute. They want you to go to Appendix C. So here it is. Our Appendix C shows the bug class, but it also shows the box bug class. Let's see. Here's the box bug class. All right. All right, so what does it do? It imports bug, and look at this new word, extends. Have we ever used that before? In the line where we define our classes, public class box bug, notice this new stuff, extends bug. That means that box bug, it will inherit everything in the bug class unless you override it. Huh?
And it'll be different, and so box bug would say, like, how far your side length is.
Right, and there it is. It's got steps and it's got side length. So when steps equals side length, it'll turn and reset steps to 0 or something, right? Notice how that's different from the bug class itself. Go back to the beginning of Appendix C. Whoa. All right, the box class imports actor, grid, and location and color. And look what it does. Public class bug extends actor. So it inherits everything that's in the actor class except anything that it overrides or adds. And look what it does. The bug constructor sets the color to red, or there's an overloaded bug constructor where you can specify the color. Right? Didn't we do that with the line class? We had 3 different constructors for the line class. So it was an overloaded line constructor. This is an overloaded bug constructor. Okay. It has an act method, if, can, move, move, else turn. All right. It has a turn method, get the current, set the direction to the current direction plus half right, which if you look at the finals, it's 45 degrees. All right. Then there's the move method. Oh my God, we got to talk about this. And there's the can move method. Oh gee, we got to talk about that. Yep. But then notice that so the naughty bits in the box bug are steps and side length, but the naughty bits in bug, well, there aren't any. Where are they? I don't see any. Except what's in the actor class, I guess. There's some naughty bits in the actor class, like the color and the location, all that kind of stuff. But there's no special naughty bits in the bug class, but we're adding naughty bits to box bug because it needs to know how far it's gone and when to turn, right? All right, so look what you can do. You can initialize a box bug constructed with a certain side length and initialize steps to 0. And then look at the act method. If steps is less than side length and can move, increment steps. Else, turn, and set steps back to 0. Isn't that what we said? When it turns, it has to do turn. All right. Okay, we'll leave it at that. Continuing tomorrow. Bye-bye.